Hello students. So today we are going to cover a very important topic that is called congruency of triangles. Why is it so important in class 9? Because the concepts of congruency of triangles will be again repeated in some way or the other in class 10 also. So to start with, let's first understand what do we mean by congruence of triangles. Now, in this, we have two words, congruence and triangles. Triangles, we all know it is a three-sided closed figure. But what do we mean by congruence? Congruence in English means exactly equal. Congruence here means exactly equal. Now, we have converted this word congruence into a simpler form whose meaning we already know, right? So, for example, if I ask you a question, when can we say that two line segments are congruent? Line segments. When are they congruent? Then I can also ask you, when can I say that two circles are congruent? So, for line segments to be exactly equal, they should have the exact same length. That is, they have same length. If I say that two line segments are congruent, that means they are of the same length, or vice versa is also true. That is, if I say two line segments are congruent, then we say they have the same length. Now, when are two circles congruent? Two circles are congruent when they have same or equal radius, because the circle is defined by a radius, right? So circles can be congruent if they have the same radius, or we can also say the same diameter, one and the same thing, because diameter and radius are connected to each other. All right. Now, for instance, I draw two lines, right? The first line here is, say, AB, and the second line segment is, for instance, is CD. And I say that these two line segments are equal, for instance, of 5 centimeter each. Now, what do I try to do is, I try to pick up this line segment CD and keep it over AB. What do I do is, I pick up the line segment and keep it over AB, like this, with the red line. The red line is denoting CD, right? So this is now CD. So if I ask whether you are able to see AB clearly, no. AB is behind CD, or we can say, in other words, that CD has overlapped AB. This is another perspective of watching or seeing two things, two line segments to be congruent, or two things to be congruent for that instance. So if two things are congruent to each other, they overlap each other. That means if you keep one thing over the other, the second thing, the thing that is behind, will be hiding behind the first thing. All right. So this was the basic meaning of congruency. Now let's move to the topic, that is congruence of triangles. Now, how can we say two triangles are congruent? As we know, triangles is a combination of sides plus angles. Based on these, we have classification of triangles based on the measure of each angle, that is right angle, obtuse and acute angle, while we also have classification of triangles based on the measure of the sides, that is equilateral, isosceles or scalene triangles, right? I hope you all must be knowing this. So triangles as a combination of sides and angles, we cannot say one triangle is congruent to the other just like that. We need to have certain criterias for it, and those criterias are made up of these combinations, that is sides and angles. The very first and the simplest being side side congruency. Side congruency. As the name must be suggesting, you got an idea already that what do we mean by side congruency. Here, my task is to prove two given triangles. That is, these two triangles to be congruent to each other. It can be of any orientation, as I have drawn here also. So let me mark these as A, B, and C. This is A, B, and C. While the second one, I'm marking it as P, Q, and R. And I'm giving you the measure of the sides also. For instance, AB is 5 centimeter, BC is 6 centimeter, and AC is 4 centimeters. While here I have QR as 4 centimeters, PR as 6 centimeters, and PQ as 5 centimeters. So here I can clearly see that the sides of the first triangle, that is ABC, are equal to the sides of the second triangle PQR, right? And if we write it in order, what do I write is side AB of the first triangle is equal to side PQ of the second triangle, both of them being 5 centimeter each. The second, that is BC, which is equal to 6 centimeter, is equal to PR, which is also equal to 6 centimeter. And the third one is AC, which is equal to QR, which is equal to 4 centimeters each. So I can say these two triangles are exactly same or equal to each other or congruent to each other. Now, what is the geometrical symbol? How do I write that triangle ABC is congruent to triangle PQR? Do not write triangle ABC is congruent to triangle PQR. Instead, we have a short form is congruent to. In geometrical notification is written as this. This is the symbol for is congruent to. So I write it as triangle ABC is congruent to triangle PQR. This is the exact statement that we write. Now we have a very important thing to note here. We need to write the names of these triangles such that the corresponding parts fall at the same place. Now, what do we mean by this? Corresponding parts falling at the same place. As we can see, I have three vertices ABC in the first triangle and the second triangle also. And here A is at which position? A is at the first position in the name of the triangle, right? Likewise, B is at the second and C is at the third. And by the combination of these vertices 1, 2, 3, I can make up the sides of the triangle. Yes. If I take vertex 1 and 2 together, I form a side which is called AB, right? The second and third vertex, it is forming a side BC, while the first and the third vertex is forming a side which is AC. Now I need to check while writing the names. I need to check whether the side AB that is coming at the first and the second position, is it equal to the side which is formed by the first and the second position here? PQ. PQ is of 5 centimeter. AB was also 5 centimeter. So by this I can say that the first part is equal. So triangle PQR. But this name could also have been triangle QPR. Yes or no? Because PQ and QP represents the same side. So only one of them is correct, and that will be confirmed by the second pair, that is vertex 2 and 3. Vertex 2 and 3 in the first triangle is forming the side BC, which is of 6 centimeter. While here, if I take triangle PQR, the second and the third QR is of length 4 centimeter here. So this name probably is the wrong notation, and we write triangle ABC is congruent to triangle QPR and not PQR. So the correct naming would be triangle ABC is congruent to triangle QPR. I hope you got it right. All right. Now let us understand with another example how do we write the correct names. All right. I'll just draw two other triangles here. The same concept. The first triangle here, and let me draw it with another color. This is the second triangle. For instance, this is again A, B, and C. A, B, C, and this is P, Q, and these are two triangles. Again, I'm giving you the sides. For example, this is 13 centimeter, 12 centimeter, and 5 centimeter. Here also, for example, this is 12 centimeter, 13 centimeter, and 5 centimeters. So I can easily say that these two triangles are congruent because the sides are equal in length. Like the first side AB is equal to the side PQ 5 centimeter, AC and QR are equal to 12 centimeters, while BC and PR are equal to 13 centimeters each. So what do I need to do is I need to decide the correct names. All right. So first let me fix the name of the first triangle, that is triangle ABC. Now triangle PQR can have different combinations, right? So I'm writing down all the combinations and then I'll decide which name is correct. Okay. So the first can be triangle PQR, then we could have PRQ, then we can have QPR or triangle QRP or triangle RPQ, and the last one could be RQP. I have these 6 possibilities in which I can write the names. All right. So here, what do I need to check? I need to check two sides of the triangle to confirm whether the names are correct or not. By one side, it can be ambiguous. You can say it can be correct or it cannot be correct. But to confirm, what do I need to do is I need to check at least two sides. All right. So here in the first triangle, as I fixed the name here, AB. So at the first and the second position, we should have a side which measures 5 centimeters because AB here in the first triangle is measuring 5 centimeters. So here, let us check whether in these names, the first two letters are representing a side which is 5 centimeters. In the first, PQ, yes, it is 5 centimeter. It can be a possible name. PRQ, this is absolutely wrong. Why? Because PR here is of 13 centimeter. Then QPR. QPR can also be a possible outcome. Why? Because here QP is also representing a side which is 5 centimeters. Now let's move to the next QR 12 centimeter, RP 13 centimeter, RQ 12 centimeter. So we have cancelled out all the other possibilities. The names could be either PQR or QPR. Now to confirm, what do I do is I check any second pair. Let us check BC. So BC here is representing 13 centimeter. Here, if I in the first name QR is of 12 centimeter. Therefore, I deduce that the first name is also wrong, and the correct name again comes out to be QPR. So the final statement would be triangle ABC is congruent to triangle QPR. Sorry, QPR by the rule of SSS congruency. I hope you got it. So this was the first and the simplest rule out of the other rules that we are going to learn here in the class. The first rule was SSS. Now let's come to the second rule, which includes an angle, SAS. So this is side, angle, and side. So this can be the full form for SAS, that is, two sides and an angle of one triangle should be equal to two sides and an angle of another triangle. Now here I have a catch that I'll let you know just after this example. So let me again draw two triangles here. So these two triangles, let us name them as PQR, PQR, and say X, Y, Z. And I'm giving you that PQ measures 6 centimeter. Here XZ measures 6 centimeters. PR is measuring 7 centimeters. Here YZ is measuring 7 centimeters. And I give that this angle is 70 degrees and here this angle is equal to 70 degrees. So by the definition, by the rule, side angle side, these two triangles are congruent to each other as PQ is equal to XZ. Then we have PR equals to YZ and angle QPR is equal to angle XZY equals to 70 degrees. So by this we conclude that these two triangles are congruent to each other and we can write the correct names as per the knowledge that I have just given you. Now for instance, this 70 degree would not have been here. This 70 degree would have been somewhere else. For let me draw it for you. For instance, this 70 degree is not here in this. This 70 degree falls somewhere else. That is, for instance, it falls here. Now, will I say that these two triangles will be congruent? Because here also we have two sides equal and one angle equal. But here we cannot conclude that these two sides are congruent to each other. Why? Because this angle here is not included between the sides which are equal to each other. Here in the first triangle, I can see the arms of the triangle, 6 centimeter and 7 centimeter. But here in this second triangle, XYZ, the arms are not 6 and 7 centimeter. One of the arm is 7, but the 6 centimeter side is the opposite side of this. So I usually tell my students that side angle side is, we learn it as side included angle. The angle that we are considering here should be included between the sides that are being given equal in the question. So here, if this would have been the question, they are absolutely not congruent to each other. Why? Because the angle was not included between the given sides. I hope this is clear. All right, so this was our second rule, that is side angle side. The third rule that we have is a little different, not very different. It is ASA. You can make out what is the full form. It's angle, side, angle. This is the full form. And here also we use the same concept, that is we learn it as side included angle and side. Now what is the reason behind it? For instance, I tell you that I have these triangles. All right. The measure of the sides or the angles here, for example, is 30 degrees. And this is 45 degrees. And this is of length 10 centimeters. And another triangle is being drawn. Now I mark the angles here. Here, this angle on the left hand side is, for example, 30 degrees. This angle is 45 degrees. Are these two triangles congruent to each other? Absolutely not. Why? Because the included side in between them is not equal. For instance, this is 3 centimeters. But yes, this triangle is possible. All of you agree? This triangle is possible because on the same base we can definitely draw two angles, which is 30 and 45 and 30 and 45. It doesn't matter what is the length of the base here. It is only possible that they are equal only and only if the included side between the angles, that is the base that I'm talking about here, will be equal in length. So here the included side, which is marked 3 centimeters here, if it would have been 10 centimeters, then we would have said that yes, these two triangles are congruent to each other. So let me draw another triangle which is congruent here in this case. If this would have been the case, that this is again 10, this is 30, and this is 45, then yes, these triangles, let me name them also, A, B, C, and X, Y, Z, would have been congruent to each other. Keeping in mind again the correct namings of the triangle. All right, keeping in mind what the namings of the triangle. So if I conclude what should be the correct names here, it is a little easier as compared to side congruency. Why? Because we have angles here. So if I would have written triangle ABC is congruent to probably ZXY, it is a possible name of this triangle. So I just checked the name of the first letter only. Instead of sides, we can now check the measure of the angles. So angle A here is unknown, but we can definitely calculate it by angle sum property. But here in the second one, Z is of 45 degrees, and obviously angle 1 or angle A here is not 45. So this is a wrong name. What could be the correct name? Triangle ABC is congruent to which of the triangle? Triangle X, because A is unknown, X is also unknown. Then we have B, which is of 30 degrees, and here in the second triangle, Y is of 30 degrees, and the last vertex, the leftover vertex is XYZ. So this will be the correct name of the triangles. So till now we have learned three congruency rules, that is side, and angle, side, angle. These three rules are very important, and in one form or the other they'll be used in class 10th also, but the topic is a little changed. It is not congruency but similarity, and you learn what do you mean by similarity in the higher classes. Okay, so I hope this this topic is made clear to you, and we are going to attempt the questions now, some questions based on what we have learned. Very simple questions. I'm not going to do very hard questions in the first class itself. You will revise whatever is given there, whatever I have taught you today, and then in the next class we'll move to a little higher order or lower order thinking skills, and then we'll move to thoughts. Okay, so let us start with the first question here. Here I am given with a figure. It's like this. And I mark the vertices as A, B, C, and D. And I am already given with the information that side AB is equal to side BD. I am not concerned about the lengths. If it is given in the question that AB is equal to BD, whatever will be the length, it does not make a difference. We just need to know that what sides are equal to what sides. Second, I am given that AC equals CD. And now I need to prove. What do I need to prove is, I need to prove that triangle ABC is congruent to triangle DBC. Now it's a very, very simple question. How? If I consider these two triangles, this triangle number 1 and this is triangle number 2. In the first triangle, I am already given AB is equal to BD. It is given in the question. Then we have AC equals CD. This is also provided in the question. And as I know that a triangle has three sides. Now, if I ask you what is the third side of the first triangle, ABC, the third side here is the leftover side, that is side BC. And now if I ask you what is the third side of the second triangle DBC, the third side of the second triangle DBC is also BC. So if BC falls in the first triangle as well and in the second triangle as well, can I say that BC will be a common side to both of the triangles? And whatever the length of BC is, it will always be equal, right? So here in the proof, what do I write? First, I write which triangles am I taking. So I'm taking triangle ABC and triangle DBC. I'm considering these two triangles and I'll write AB equals BD and AC equals CD. And I also need to mention in brackets what is the reason behind it. The reason here in this question is that it is already given in the question. And the third, that is BC equals CB. Why? Because it is a common side to both the triangles. So in this question, I have considered only the sides of a triangle. So by S congruency, these two triangles are congruent to each other. I hope you got it. All right. So this is by SSS congruency, these two triangles are congruent to each other. Now let's move to another question based on another congruency rule, that is SAS. Okay. So let me draw a figure. By the questions that we are practicing, no, you need to know or note it down somewhere what extra things that we have learned from the questions. Like from the first question that we just did, no, what do we learn is a side which is falling in both the triangles is common to both the triangles, and it can be taken for granted in some way or the other that yes, whatever the length will be, it will always be equal, right? Okay. Now, for instance, I have again these two triangles A, B, C, and P, Q, R. And I have this angle as 70 degrees. This side is 6 centimeters, 10 centimeters, and 8 centimeters. And here I have this side as 6 centimeters. Sorry. The information is a little different. This is 10 centimeters. This is 8 centimeters. Here this is 10. This is 6. And this is 8. So by SSS, yes, these two triangles are congruent. But for example, I don't have the last side of this triangle, while what I have is I have this angle as 70 degrees. So upon checking, we have an angle equal 70 and 70. And now let us check the arms of the triangle. As I told you, the arms of the triangles should be equal, right? Here, the first arm BC is of 10 centimeter. Here also, the first arm is of 10 centimeters. The second arm here is of 6 centimeters. Here also, the second arm is of 6 centimeters. So, what do we conclude is by side angle side. Side angle side, we have these two triangles as congruent triangles. Okay. All right. So in this class, we'll be stopping here. And what do you need to do is you just need to focus on revising the concepts that we have just learned. All right. And in the next class, we'll be full on doing the questions based on these three concepts and learning two more concepts of congruency. I hope you got it and you enjoyed the class. So we'll meet in the next class. Till then, bye-bye.